Okay, so now that you've determined what fits within the realm of science, now we're going to look at how we test things using the scientific method. Now, when we test things using the scientific method, the first thing that we have to have is some sort of an observation. We observe something. The example that I have in your book is we observe that the sky is blue. All right, that's a common observation. We can all observe it. It never changes. It may be a different shade of blue in one area versus another, but we all see that the sky is blue. Which leads us then to kind of a hidden step in the scientific method, and that's asking a question. Why is the sky blue? Okay. That's going to then lead us to our hypothesis, which is our answer. The sky is blue because the ozone layer blocks all the other colors. Right, which is what we do know to be true about why the sky is blue. But we could come up with other reasons. The sky is blue because it's reflecting the color of the ocean, the color of water. Okay, that would be just as valid of a hypothesis because in a way it's an educated guess, and that's probably something you've heard it called previously. But when we say educated guess, it means that it's a guess based on a lot of pre-knowledge, a lot of research that's been done beforehand. Not just it's your wild guess, whatever you randomly think it is, but based on what's already been done researching the color of the sky. So once we make our hypothesis, that leads us then into our experiment where we're actually testing the hypothesis. And there's two different ways that we can test a hypothesis. We can do a natural experiment, and this is where we're just observing what's naturally happening, where as the researcher, we're doing nothing but standing back and watching. Now, these are often done in situations like if we're testing earthquakes or tornadoes or hurricanes. Things that while we can do a simulation of it, we can't actually cause a hurricane, cause an earthquake, cause a tornado. And in a way, even if we could, we probably shouldn't. There's a lot of other ethical ramifications that can come along with that. So we can just observe it. We also see a lot of these type of studies where we're looking at wild animal. Let's say we're looking at breathing behaviors of chimpanzees. Right? If we go to do anything, if we set anything up, if we feed them to bring them to a particular location, we then may be manipulating the situation and causing us to not really get a good idea of what really is happening. So that's where we'd want to use a natural experiment. We just sit back, we watch, we take data, and then we finally make our conclusion. The other type of experiment is called a controlled experiment. And with a controlled experiment, this is where the researcher actually is manipulating the situation. They're causing the situation to happen. So drug tests is a really good example of controlled experiments. Things where the researcher is controlling various aspects of the situation. They're providing the medication. Maybe they're controlling other aspects like what food is being eaten, how much exercise is being done, things like that. So all of those different, what we call variables that the researcher is manipulating, we call those controlled variables. All right? Now, only in a controlled experiment are we going to have controlled variables. However, in either type of experiment, whether it's natural or controlled, we have two really, really important variables, the independent variable and the dependent variable. And you can kind of think of these as a cause and effect. So within our observation, we're going to notice something, and then with our hypothesis, we come back with the cause of that. So the cause then is going to be our independent variable. The effect is going to be our dependent variable. So if we go back to why is the sky blue? The sky is blue because layers of the ozone block all the other colors. Then our independent variable, the cause, is going to be the layers of the ozone. And the dependent variable is going to be the sky being blue, the color that is able to pass through that ozone layer. Okay, so cause and effect. So when you're writing your hypotheses, you want to keep that in mind, that you need both that independent variable and the dependent variable listed clearly in your hypothesis. Once the experiment is completed, you've taken all your data, you've written down all your information, you then synthesize that information into some sort of results and or conclusion. In other words, what happened, and did it support the hypothesis, or was the hypothesis rejected? Did we discover that we were wrong, or maybe partially wrong? Either way, we need to go back and redo the experiment. Even if we got it right, even if our hypothesis was supported, we want to go back and test it again and again and again, just to make sure that we're always right, that it wasn't just a fluke that we happened to get it right the first time. We want to prove it over and over and over again. Once it's been proven over and over and over again, we publish our results. We put it out for other researchers to try and practice and see if they get the same results. And if they do, eventually over time, it becomes a scientific theory. So to recap our steps of the scientific method, we start out with that observation. Then we kind of ask that hidden question, why is this happening? Leading to our to our hypothesis, to our experiment, to our results and conclusion. So as you complete the exercises in your lab book on the scientific method, make sure you are understanding each step, and make sure when you're writing your hypothesis that you keep in mind what's your independent and what's your dependent variable, because those are going to be what really makes your hypothesis valid, right? Is having both of those parts in it, the independent and the dependent variables. Complete those exercises, submit them online, and let me know if you have any questions.